So in 13.7 you learned about the trig graphs, and now we're going to be translating them. So we're going to be doing some phase shifts and some vertical shifts. So copy down the title and your essential question. So before we begin with the trig functions, let's review all of the things that we've learned that have different shifts. So we started off with this. So what does this graph look like? So it has an x squared in it. Those graphs are called parabolas, and they look like that. And how does h affect it? H moves it left and right, but because of this negative sign, it's opposite of what we think. So positive goes to the left, negative goes to the right. And then k moves it up and down. So if it is the direction that we think it is. So if it's positive, it goes up. If it's negative, it goes down. But this is a parabola. How about a square root? What does that graph look like? Well, that starts at 0, 0 and kind of swoops up. It's the inverse of the parabola, so it's like a parabola turned on its side. But because to be a function, it can't have the bottom half of the parabola. And how do h and k affect it again? Again, h makes it go left and right, but it's negative, so it's opposite of what we think. So plus goes to the left, negative goes to the right, and then k moves it up and down. Again, in the direction that we think it's going to be. Up for positive, down for negative. So we've got square roots. What else did we learn that has the same h and k movement? Absolute values. What do absolute value graphs look like? Those are V-shaped graphs. That's not a very good V-shaped. I'll try that again. That's a little better, but it should go through 0, 0. And if h, again, it's going to move it left and right. If it's positive, it goes to the left. Negative, it goes to the right. K moves it up and down. And it's the way that we think it is. If it's a positive k, moves up. Negative k, moves down. Ooh, how about this one? AB raised to the x, and then we've got the h and k in there. That is going to be an exponential function. So it goes right along the x-axis and swoops up. Again, h is going to move it left and right, opposite. K is going to move it up and down. So it can move this way, and it can move up and down. And how about this one? So a hyperbolic function is what this one's called, and it has a swoop in this quadrant, quadrant 3, and then in 1. So it has some asymptotes. And it can move the same way. So h moves it left and right. Oh, they should be together as a group. Well, imagine both of them moving left and right together. Or the whole thing can move up and down. So it can move up and down like that. Now, all of these also could be affected by an a value. Put those back together, slide that back into place. So these all could have an a value, which would be out here. I didn't write those in all of them. A value affects the steepness, but also if a is negative, it would do the reflection of the graph. So let's look at this with sine. So sine has a phase shift, meaning that it can move it left and right, and just like we kind of expect, it has an h, or we call it h. So we gave 2 examples of sine there, but this works for sine, cosine, and tangent. And you can copy all of that down. Vertical shift would mean that it's moving up and down, and again we're calling this k. So it goes up if it's positive k, down if it's negative k. This works for sine, cosine, and tangent. And so here's our summary. We have an amplitude, a period, a phase shift, and a vertical shift. Now the steps determine how you're going to graph these, so make sure you write down these steps as well. All right, let's go into some of these problems. So we've got this one right here. Y equals 2 sine theta plus 20. So what is our amplitude? Amplitude's always in front of sine. Our amplitude in this problem is 2. What is our period? Our period is always 360 divided by the number in front of theta. There's no number there, so it's just 1. So that's just 360 degrees. Phase shift. It's got a plus 20 right here. So remember, it's opposite of what we think. So that means it's going to go to the left 20. So how are we going to draw this? First of all, we need to draw a regular sine graph, and then we'll use that to help us make our new sine graph. So our phase shift is at 360. I can throw that on here somewhere. How about I just go right here, 360. And then we would graph sine going up to 2 and down to -2. But I need to find my 180. That's right there. Oh, maybe let me move 360 over. Make it a little easier on myself. Put 360 right there. 180 then is right in the middle here. So it starts at 0. At 180 it hits the 0 again. 360 is back to 0 again. At 90 degrees, it's going to be up at 2. And at 270, it's going to be down at -2. So now this part you want to just sketch in lightly in pencil because this is not actually your graph. So I can erase mine, so I'm going to go solidly, but you might want to do this as a pencil. There's our graph, but we need to move this over to the left 20 degrees. So that means each one of these needs to be moved to the left, each point. Now, if we think about this, each of these is 30 degrees, so we need to go almost a full block, but really just 2/3 of a block. And then we connect these green points. So let's remove those, all these dots and everything. Oh, I missed it. There we go. There is our answer. Let's try this one. Half cosine theta plus 3. So find the amplitude, vertical shift, the equation for the midline, and then graph it. Okay, so vertical shift. That would be what's added at the end, plus 3. That means it's going to move up 3. What is our amplitude? How high does it go? That's right here, 1/2. And what is our period? 360 divided by the number in front of theta, right there, which is a 1. So that's 360. It looks like, though, they're going to... Let's do it in radians, just to be a little bit more familiar with that. 360 is 2 pi, so we'll go 2 pi divided by 1, and it's 2 pi. So now the midline is normally at the x-axis, but because of our phase shift, it moved up 3, so the way we write the equation for the midline is y equals 3. So on your paper, let's put a dotted line at y equals 3. Just lightly dot that in. That's kind of like our new x-axis. Our graph shifted up, and we'll treat it like we would the x-axis before. All right, let's put our period in at 2 pi. That ends over here. We'll just put over there. So this would be pi. This would be pi over 2. And this would be 3 3/2 pi. 3 pi over 2. So cosine starts high, swoops down, and comes back up high again. So we are going to start at our amplitude, which is 1/2. So you go half the way above 3, half of a box above 3. And then we end at 2 pi at half again. Halfway between those 2 points, we're at our minimum. And halfway between those points is our x-axis, which is our midline now. And we connect our points. All right, this one does not have a phase shift, so we're just done. That's our graph. If you want to clean it up a bit, you could erase your midline. That part's not really essential, though. The midline is more just a guide for us. All right, how about this one? It's got a lot of stuff to it. So let's start with our amplitude. Where do we find our amplitude in there? 3 is our amplitude. Period. Well, that's going to be an indication what to use for a period. Look right here. Is that in degrees or radians? It's in radians. So it's going to be 2 pi divided by pi over 2, which is multiplied by the reciprocal. Our period is, hold up just a second. Yep, I did that one wrong. I shouldn't be dividing it by the phase shift. I should be dividing it by the B value, which is 2. So that one I didn't even need to do copy, change, flip. It's just pi. Phase shift, that's what I was trying to use before. It's pi over 2, and it's negative, so negative means it's going to go to the right. And then our vertical shift is plus 4. So that means it needs to go up 4. So let's start by graphing our midline. Our midline moved up 4. So perhaps we want to extend this paper just a little bit. Okay, I've modified my paper now, so I actually have room to graph this. So my midline is going to be at 4. I'm going to just draw a light dotted line here. That's going to be our guide. Now our amplitude is 3, so it's going to go up 3 and down 3. So it's going to go up to this line and down to that line. It's a sine graph, so I know sine looks like that. And I need to finish by pi. So let's put 2 pi here just to be consistent. So this is pi. Pi over 2, 3 pi over 2. So by the time I get to pi, I need to be finished. So it starts at our midline, ends at our midline. Halfway through, it's at our midline. Now our lower middle is up to 3 above the midline. And then we go down 3 below the midline. And just to make it easier on myself, I'm going to put those dots again. Okay, now remember, we're going to have to do a phase shift on this, so lightly draw this in. So there's our graph. And now we need to shift it to the right, pi over 2. So we need to move it to the right that far. So each of these points has to move over 3 blocks. So the graph ends up looking like this. And I need to go back now and kind of estimate where this would be. Like that. And now you need to get rid of the original one. So there's our graph for that one. All right, let's look at a word problem then. So take a second to read through this one. Okay, so after reading this, we can figure out that our midline has to be halfway between 6 and 10. So what would be halfway between 6 and 10? That would be 8. So what is our amplitude then? To go from 6 up to 10 with a midline of 8? That means that it's rising 2 and going down 2. So it has an amplitude of 2, and it says we have to use a sine function. And our midline is 8, so we put plus 8 here. But what is the number in front of theta? So if we do 3 waves per minute, that means each one is going to be 20 seconds. So if we take 2 pi, which is a full circle, and we cut that, divide that by the 20 seconds, that means we're going to take it and have pi divided by 10 as our b value. So we need to have 3 cycles done by the time that we get to a minute. So if we record this as 20 seconds, 40 seconds, 60 seconds, we need to have 3 cycles done by then. And so we'd start 1 here, end it at 20 seconds, halfway, it goes up like that. So the graph is going to look like this. And it is a good idea to keep adding these dots, otherwise you can find yourself getting really off on your graphs. is the waves of the pool. All right, that's the end of the lesson, so you can write your questions and your summaries.